Okay, so already we have learned through the activity the concept of median and altitude. So let's understand the definition. So what we have learned? So median of a triangle. Suppose you have this kind of triangle PQR. D is the midpoint. By folding paper I will explain you, and P is the vertices. This is so PD is the median of a triangle. I explain you, for a triangle we have three median. We have three median. Okay. Now median means opposite vertex and this point C is the midpoint of the given line segment. A is the midpoint of PR and B is the midpoint of PQ. Okay, so PC is the median, QA is also median, and PR is also median. So what we can say for this? The line segment AD joining the midpoint of BC to its opposite vertex, so it is known as the median of the given triangle. How many median can a triangle have? That also we have considered that a triangle have three median. Now for the altitude, what we have discussed, altitude means it gives the height of the given triangle. So for that also we have almost three altitude for a given triangle. Okay, if you have considered such kind of diagram, P, Q, R. So this gives you the height of. Why? Because it makes a 90-degree angle over here on the base. That's why it gives the height of the given triangle. If you draw like this, draw like this, draw like this, but it will not make the 90-degree angle over here. So that's why they all are not an altitude. Okay? Okay, for a triangle it has three altitude. Same perpendicular line you can draw over here like this. The same perpendicular line you can draw from this point. Okay, so for a triangle also we have three altitude. And here the opposite side, whatever point you consider, that is the midpoint. It is compulsory, it should be a midpoint, it has to be a midpoint. But here, if you join P with this vertex, suppose A, but this is not a midpoint of QR. If you consider D, so this is not a midpoint of PR. If you consider this C is not a midpoint of PQ, then also they represent altitude. So altitude doesn't mean that you have to join the midpoint of the opposite line segment. Okay? So this is the difference between the median and midpoint. Sorry, median and altitude. Now move on to the next topic. Think and answer. Let's see. The question is, how many altitudes can a triangle have? We have discussed three. Second question, draw a rough sketch of altitudes from A to BC. We have given three diagrams like this. ABC. Then we have given a right angle triangle. ABC, and this is your obtuse angle triangle. It is also ABC. Now what is the question? We have done the rough sketch of the triangle. Now we have to draw the altitudes from A to B. Means we have to draw altitude from A and join to the opposite sides of the triangle, that is BC. Let's see. So I draw the altitude, not median, remember I draw the altitude, name it as D. From this A, I draw the altitude on BC, that is AB. From A again I draw the altitude. If you extend this line, so this is also my altitude. Altitude means you have to find the height of the given triangle. Okay, so for this diagram, if you consider, I am getting the altitude inside the triangle. For this kind of triangle, I am getting the altitude, that is the one side of the triangle. This is right angle triangle. This is your obtuse angle triangle. When I draw the altitude, it is outside the triangle. Why I am explaining this to you? Because the next question is based on this. Let's see. We have drawn the altitude. Now next question is what? Will an altitude always lies in the interior of a triangle? Always? No. It is sometimes, not always. Okay. For such kind of acute angle triangle, we are getting the altitude which is interior part of this triangle. But for obtuse angle triangle, we are not getting the altitude inside the triangle. It is outside the triangle. And for right angle, we are getting the altitude, that is the one side of the given triangle. Okay. Can you think of a triangle in which two altitudes of the triangle are two of its sides? Of course, this is right angle triangle. This is the one side, this is also altitude. And if you draw the triangle like this, where this is your BC and this is A. So now this is your altitude. This is also one side of a triangle. Okay. So for right angle triangle, its both sides behaves like the altitude because it being the height of the right angle triangle. Okay. Can the altitude and median be same for a triangle? No. That also we have explained in the previous. For median, the opposite side, whatever is that, the midpoint we have to consider. And that midpoint we have to join with the vertex. But here, D, it does not midpoint. There also D is not a midpoint. For altitude, it is not compulsion that you have a midpoint of the opposite line segment. So this is the difference. So this is all about your median and altitude. Next, we have exercise 6.1. Let's see. This you will do by yourself, but I am just explaining. In triangle PQR, suppose you have a triangle PQR. This is your exercise 6.1. What is given? PM. Okay, and this is weight. This I have to extend so that I will get this separate. Here. And this is the midpoint, that is P. Now what is the question? In triangle PQR, D is the midpoint of QR. Then PM is what? PM is what? It is altitude because it makes a 90-degree angle with the line segment QR. So PM is what? PM is an altitude. PD is what? D is the midpoint. So obviously PD is the median. Is QM is equal to M1. Distance this is equal to this? No. Okay. Second question. Draw the rough sketch for the following. Okay, draw the rough sketch for the following. Let's see. See the first question. We have to draw the rough sketch. What is given? Triangle ABC is given. Question number 2. In triangle ABC, D is a median. So draw the triangle ABC where B is the median. Median means we have to find the midpoint of this and we have to join this. So this B is your median. So this is the diagram. Second, in triangle PQR, PQ and PR are altitudes of the triangle. When it is possible, when you have a right angle triangle PQ and PR. verify by drawing a diagram if the median and altitude of an isosceles triangle are same or not. So what is an isosceles triangle? We have seen that isosceles triangle is nothing but where two sides are equal. Suppose we have P, Q and R, and this gives you the height of this PN. Suppose you have so, and if you measure the distance between QM and MR, this is also equal. So what we can say, PN